Lesson 10.6, Pythagorean theorem. These are in word problems, so you have to draw the triangle out. Number 1 says you start driving east for 5 miles, turn left, and drive north for another 12 miles. At the end of driving, what is your straight line distance from your starting point? Round to the nearest tenth, so make sure you're looking at what they want you to round to. Hopefully we know our basic directions, that it goes north, east, south, west. Never eat soggy waffles, never eat sour worms. I've heard all kinds of stuff. Okay, so you're going to just start driving somewhere. You're going to go east, which would be this direction, for 5 miles. Then you stop, and so if you're driving here, this would be left, which means you're going north for 12 miles. Which obviously this is not going to be drawn to scale. At the end of driving, what is your straight line distance from your starting point? Well, this was your start here. This is where you stopped. So your straight line distance has now created a right triangle where this is your hypotenuse. So we want to solve for this. So it'd be 5 squared plus 12 squared equals x squared. We should be really good at those and able to get an answer on our calculator quickly. And I ended up with an answer of 13 miles. Okay, number 2, ladder problems. You place a 24-foot ladder against the top of a 20-foot building. How many feet will the bottom of the ladder be from the bottom of the building? So my ladder is my angled line here, my hypotenuse. It is 24 feet long, and it's going against a building, which would be a vertical distance of 20 feet. This is the bottom of the ladder, and the distance it is from the bottom of the building. So normally this would be something like inside a building, outside in the grass. You would never have a line here, but this is just showing that we're trying to find the distance of building to bottom of ladder. And so I would have x squared plus 20 squared equals 24 squared. Solve that real quick. And you should get 13.3 feet rounded. All right, number 3, an altitude is drawn from the vertex of an isosceles triangle. So let's just stop and think of that. An isosceles triangle, we've learned, has 2 congruent sides, and I always draw it like this, to where these are my congruent sides. This would be my vertex angle. This is the base. An altitude is coming from the peak here straight down. And what that does is it creates a 90, and it also divides this into 2 congruent or exactly the same triangles. As a result, the altitude cuts the base, this is our base, into 2 equal parts here. The length of the altitude is 13 inches, and the length of the base is 8. That means of this whole triangle, it was 8, but now this little triangle would be 4, and this one would be 4. Find the triangle's perimeter. So I'm going to have 8, and I'm going to have to know what these sides are, which they'll be the same, to add those together to get the perimeter. And so I'm just working in one of these little right triangles. So we would have the legs be 4 and 13, and I'm trying to find the hypotenuse. Okay, you get 13.6 when it's rounded. And then to find perimeter, I would just have my 13.6. You could have it doubled or just plus another 13.6 plus the bottom side, which was 8. So if I take that times 2 and add 8 to it, you should get the perimeter to be 35.2 inches. Okay, and then the last one is the hardest one. I kind of enjoy these though. We got a 20-foot ladder. The ladder is not going to change its length. So we got a 20-foot ladder leaning against a house so that it reaches up 16 feet. So here to here, this is 16. If Christian grabs the ladder at its base, so that would mean you're going to grab it here and pulls it 2 feet farther from the house. So you're going to pull it out back this way, 2 feet. How far up the side of the house will the ladder reach? Now, hint, the answer is not 14 feet. It's not that simple. So what happens if I take this ladder and I start to pull it out farther? Then that means that from here, I'm going to now have my ladder still be 20 feet, but now it's not going to touch up quite to 16 feet. It's going to be lower than that. So this is actually a 2-step problem. First step is I need to figure out how far is the base of the ladder from the house to begin with. Then what I'll have to do is add 2 feet to that. Okay, so first this original triangle, I'm just finding how far is the base of the ladder from the house. So I would have my legs be the x and the 16 our hypotenuse to be 20. And so that gets you, okay, square root of 144, that would be 12. Okay, so right now, this is 12 feet. Well, I'm going to pull that back 2 more feet. So now I would have to add the 12 plus the 2 to make this a total distance of 14. So it's like I've created a new triangle where now I'm 14 feet away from this house. And my ladder is still 20 feet. But now how high up am I? So I would have to do Pythagorean theorem again. And so I've got 14 squared plus x squared equals 20 squared. Which gets 14.3 feet. Okay, so that's the only way to do it, is find the missing leg of the original triangle and then add how many feet farther you're pulling it back, and then do Pythagorean again to figure out how high the ladder is up on the house.